In this video, I will be discussing topic 4, linear equations. In this topic, we'll learn about first-order linear equations and how to solve them. The general form of a first-order differential linear equation looks like this. Ax times dy dx plus bx times y equal to cx. So notice that in linear equation, we only have y here, and then the derivative, first derivative dy dx. These are the two places where y and its derivative appear. We don't have any other terms in y or derivative of y. Ax, bx are the coefficients, and then on the side we have cx by itself. There's no y at all. That's the general format of a first-order linear equation. However, in order to solve it, we need to put it in the so-called standard form by dividing through by ax. So then we will have dy dx plus the coefficient in front of y will become bx divided by ax, and we're gonna label it at p of x. And on the right hand side, we would have cx divided by ax, and we label at qx. So what is the difference between the standard form and the general form? The standard form, we have 1 in front of derivative. And this is very important because later on when we solve linear equation, we will put it in the standard form. So in this video, I will discuss an example of where linear equations come from and the theory how to solve it. And then we'll look at another example how to solve equation. So first, consider example 1. We discussed this in the first lecture. So we have an object with mass m equal to 2 kilograms. This object here is dropped from a top of a building. And we assume air resistance is proportional to the velocity of the object. Proportional to velocity. With resistance constant so gamma equal to 4. It has a unit. It's a little bit on a unit to match up with the formula. So it's not very important when we solve the equation, but let me write it down anyway. That's for Newton seconds per meter. This is a weird unit, but as you know, in physics, we need to match up the units. So we need to have search for the resistance constant. Now the question is to find the formula for the velocity of the object. That is, we need to find a formula for v of t at time t, and t here will be in seconds. It will involve the acceleration from gravity. So we will take g to be 9.8 meter per second square. So let's see how we solve this problem. Like last time, at the time t equals 0, say the object is on top of the building like that. And at time t positive, it's somewhere down here. And as before, we're going to choose the positive direction to be downward direction. So everything going downward will be positive. So at any time t positive, we want to know the forces acting on the object. We saw this earlier in topic 1. This is the gravitational force. F G is m times g. And then we have the air resistance up here, F of d, drag force, which is up. I'm going to write minus. It's proportional to the velocity. So it's gamma times v. And we know that we're given gamma equal to 4 in this case. So Newton's second law. Newton's second law says that if we add up all the forces, so we have m times g minus gamma times v, then we have m times a, acceleration. So m g minus gamma v equal to m, and remember a, the acceleration is derivative, dv dt. So let's rewrite the equation in the format of the general format of linear equation. This is a linear equation because the unknown here, unknown is v, and we have v dv dt only. These are the two places that the unknown and its derivative appear. It's linear. But let's rewrite in the correct format. We need to move the terms minus gamma v to the other side. So I rewrite it's m dv dt plus gamma v, and then m times g without the unknown on the right hand side. Let's put in the values. We're given that m is 2 and gamma is 4, and then the gravitational acceleration is 9.8. So we get 2 dv dt plus 4v equal to 2 times 9.8. this is the general format of a linear equation. Let's put it in the standard form. So recall, standard form means that we need to turn the coefficient here into 1. Coefficient in front of the derivative to be 1. So divide through by 2. Then we have dv dt plus 2v equal to 9.8. This is the standard form of our equation. How do we solve this equation? Well, we will learn the procedure to do that here, to solve general linear equations. But for this particular example, without explaining further, let me give you a method to do. It could be calculated out of the blue, but we'll learn the reason why later on. Let's multiply through by this e to the 2t. So e to the 2t is out of the blue. It does depend on the equation. I haven't told you how to do that, how to get e to the 2t yet, but let's just do that. And we need to multiply through, meaning that e to the 2t here multiply by derivative, multiply by this, and multiply on the right hand side as well. So we have e to the 2t dv dt plus e to the 2t 2v and then 9.8 e to the 2t. You will say, well, why are we multiplying by e to the 2t to make the equation more complicated? That's right, we make the equation more complicated, but for a purpose. It turns out, now the equation is more complicated, but it turns out the left-hand side is the derivative of a product, meaning that the left-hand side is from product rule. What it means is if you take the derivative, the t of this, v times e to the 2t, then by the product rule you will get exactly the left-hand side. Derivative of the quantity on the left side, the derivative of v e to the 2t is the right-hand side. So from calculus 1, we integrate and we get v e to the 2t equal to the integral of 9.8 e to the 2t dt. This follows from the fact that derivative and antiderivative are inverse processes of each other. Derivative of this product is the right hand side, so this product without derivative is the antiderivative of the right hand side. So then we compute 9.8 antiderivative of e to the 2t is e to the 2t over 2. Don't forget to add the constant here. So we can simplify v e to the 2t equals to 4.9 e to the 2t plus c. Now, right here, let's look back if we have any initial condition. Do we have any initial condition? Let's look back at the problem. It says that an object with mass m equal to 2 is dropped from a top of a building. So when t equals 0, right, that is where initial condition we have t equals 0, the object has velocity 0 because it dropped from there. So no velocity at the beginning. So what it means is t equals 0, v equals 0. We do have initial condition. Let's plug these values in, and we get what? On the left side we have v0 and then e to the 0 equal to 4.9 e to the 0 plus c. 0 times e to the 0 is 0 and e to the 0 is 1. What we get is 0 equal to 4.9 plus c, and from here c minus 4.9. And now we look back, c equal to minus 4.9 into the equation above star here that we have after integrating, and we get v e to the 2t equal to 4.9 e to the 2t minus 4.9. Now we need to solve for v because that's what the problem asked for. The problem asked for v. Divide both sides by e to the 2t. So divide e to the 2t by e to the 2t by e to the 2t. Then we get 4.9 minus 4.9 divided by e to the 2t, which can be rewritten as 4.9 minus 4.9 e to the negative 2t. So we can use a negative exponent, and this is the solution to the given problem. The velocity of the object has this formula. So let's go back to what we did. The key is to multiply through by the magic factor here to make the left hand side of the equation derivative of a product. So in general, given a linear differential equation of first order, how do we know which factor to multiply? Such a factor is called integrating factor. I will talk about the theory a little bit, and later on I'll give you a formula for the integrating factor. So let's consider the equation in standard form. We need to begin with standard form. dy. Let me write the x here instead of t. As before, sometimes independent variable could be x, sometimes could be t. Dy dx plus px times y equals qx on the other side. It is standard form. So we want to find a integrating factor. Integrating factor denoted by this mu of x. and you read mu of x, such that so we don't know what mu of x look like, but what we want is that so that if we multiply the equation, through by mu of x, then the left hand side becomes derivative of a product. So if we multiply equation by mu of x, then we have mu of x dy dx plus mu of x and then px y mu of x and qx on the right hand side. But the key is we want the left hand side is from product rule. Left hand side must match exactly with the product rule d dx of y times y is the unknown that we're looking for times this mu of x here. We need to find this mysterious mu of x so that after we multiplying the equation through by mu of x, the left side is the derivative product. So let's see, if we want the derivative of the product, then by the product rule, we have what? The derivative of y. So dy dx times mu x plus y times, let me just write derivative mu prime of x, and that's from product rule. But on the other hand, we want to match exactly what the left hand side here. We want to match exactly with the left hand side. But if you look carefully, if we want to match this product rule with the left hand side, then what do we need? The first term is dy dx mu x is exactly the same as that term right there. So to match the second piece, mu x px y should be exactly the same as y times mu prime of x. But then y, the common y is the same here already. So we require to match, we require that mu prime of x should be the same as mu x px. That's the only thing needed. Mu prime of x is mu x times px. Then from here, we want to know what is mu of x. Well, we want to find a function mu whose derivative is the same as mu times another function. What kind of function is like that? Think about calculus 1. Like what function such that when you take the derivative, it will be the same one times another factor? Well, you get it right. Exponential function. Right? It should be exponential, but what kind of exponential? If we have exponential, sometime like here, then when we take the derivative of mu, it will be the same exponential times the derivative of the exponent. But we want above, we want a p of x here. So it should be on top, on the exponent, this should be antiderivative, because by the chain rule, we need to take the derivative later on. And this is the formula for the integrating factor. So integrating factor is, I'm just rewriting the formula above again, E integral of px dx. This is the magic factor that we're looking for any linear in standard form. So let's see how it works. Let's go back to example 1 again. We're not gonna do all the details, but look back at the equation. Here, a standard form, dv dt plus 2v equal to 9.8. How do we determine the integrating factor? So in the example, I just give you out of the hat, the integrating factor is e to the 2t, but now we can explain why. So the equation dv dt plus 2v equals to 9.8. Let's identify a few things. The standard form. Standard form, here we need to switch back to independent variable t. So I'm going to write pt, qt. That is the standard form of the equation. So from here we see that pt should be 2 and qt should be the right hand side, 9.8. QT 9.8. By the formula, integrating factor is mu of t equal to e integral of pt dt. So we have e integral of p2 dt, which is integral of 2 dt is just 2t. Normally we need to add c, but because we're only looking for one integrating factor, so no need to add c right here. So in the intermediate step, when you find integrating factor, no need to add c. And this was the magic factor I gave you at the very beginning, but now we have an explanation for it. Now let's look at another example. We solve the initial value problem. In this problem, besides the differential equation, we also have the initial condition. We have this y prime equals to 2y minus x, and the condition is y x0 equals to 1. As before, this is our ODE, and this is our initial condition. Now let's rewrite the equation in the standard form. Standard form means that we have dy dx plus px y equal to qx. That's the standard form of the equation. Our original equation is not in that format yet. And we need to rewrite as y prime. Y prime or dy dx are the same. So you could write dy dx or you could write y prime. Doesn't matter much. Let me just write y prime here. And then we need to move minus 2. We need to move 2y to the left side. So it becomes minus 2y equal to minus x. So what do we identify here? Px and qx. You need to be careful with the minus sign. Px should be everything, the coefficient in front of y. So it includes the minus sign as well, if any, that px. So in this case, px is minus 2 and qx is minus x. Hence, the integrating factor is mu x equal to e integral of px, which is minus 2 dx. And then we get e to the minus 2x. Again, we don't need to add constant c at this point. Once we know the integrating factor, we multiply standard form by e to the minus 2x. When we multiply the standard form by e to the minus 2x, we have to multiply the entire equation, left and also right hand side. So from here, multiply the equation. We have e to the minus 2x times y prime, and then minus e to the minus 2x, and 2y. On this side, we have minus x e to the minus 2x. It does not matter whether you write e to the 2x on the left or on the right, because multiplication is commutative. Need to put a few more pages here. Now, it's important to recognize that the left-hand side derivative of product. What product is that? It's always y times the integrating factor e to the minus 2x. But you should double check to make sure that what you're doing is correct. The product rule would say that derivative of y prime times e to the minus 2x, that matches with the first term here. And then we have y times derivative of e to the minus 2x, which is e to the minus 2x times negative 2, and again that matches the second together with the minus sign. So our integrating factor is correct. Now we need to integrate. So y e to the minus 2x is the integral of minus x e to the minus 2x dx. How do we do this integration here? We see from calculus 1, we do integration by parts. And the formula for integration by part, integration of u dv equal to u times v minus integral of v du. And we need to use correctly u and v. For this problem, u will be that piece and dv will be the rest, including dx. U minus x dv is the minus 2x dx. If you need to review integration by parts, please do that. It's very important. That we compute du is minus derivative of minus x, which is minus 1 dx. And you need to do it correctly, write properly by having du, dx, etc. And v is the integral of this, which is e to the minus 2x divided by minus 2. And then using the formula, so integral of minus x e to the minus 2x dx becomes u times v minus integral of v du. So let's see what we get. U is minus x and v is this. We need to multiply u times v. The minus cancel out. So we have a half x e to the minus 2x, and then minus the integral of v is here, e to the minus 2x divided by minus 2, and then du is minus dx over there, minus dx. Simplify, we have half x e to the minus 2x. We have several minus sign multiply together, 3 of them multiply together, so they will be just minus half e to the minus 2x dx. We need to do another integration. So minus a half is already here, and then antiderivative e to the minus 2x e to the minus 2x divided by minus 2. And this time we need to add c, constant c. Simplify, we have a half x e to the minus 2x, and then plus a quarter e to the minus 2x plus c. That is the integral. But how do we put back into the equation? Right here, we have y e to the minus 2x equal to the integral, and we have found the integral below. So let's rewrite it. And we get y e to the minus 2x equal to the integral, which is a half x e to the minus 2x plus a quarter e to the minus 2x plus c. At this point, we may use initial condition, which says that when x, let's go back here, initial condition, x equal to 0, y equal to 1. X equal to 0, y equal to 1. We plug in these values, 1 for y, 0 for x. and then solve for c. So this is 1 and this is just 0 plus quarter c. So you can see that c is 1 minus a quarter would be 3 quarter. But we're not done yet. We need to put this value back into the equation above, back to the equation above, which I would denote here, label as star. So c is 3 quarter. Put back in there, we have y e to the minus 2x equal to a half x e to the minus 2x plus a quarter e to the minus 2x plus 3 quarter here. And now we need to solve for y. To solve for y, there are two ways to do. We could divide through by e to the minus 2x, or it is the same time as multiplying everything by e to the plus 2x. That's the same thing. So let's do that. Multiplying through by e to the plus 2x, then we cancel those e to the minus 2x to get this. But be careful, we need to multiply. So let me write here, multiply by e to the positive 2x. And we need to do that to all here, 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 and here as well. And whenever we have e to the minus 2x times e to plus 2x, they cancel out. We get 1. And this is the final answer to our differential equation, our initial value problem. This is the end of this